This is lesson 4.7a. We are going to be graphing inequalities. Let's start by looking at this solve and discuss it problem. It says Henry is thinking of a number that is less than 17. What number could he be thinking of? So you should have said any number that is less than 17. 16, 15, 14, 0, a negative number. And let's show how we can represent that on a graph. So in your notebook, I want you to make a number line. And let's graph the number 17. So if I want to graph any number that Henry is thinking of, any number that's less than 17, we could graph 10. We could graph 0. So 10, 0. I can graph negative 10. I could make a point all the way down here at negative 200. I could make a point at in between all of these whole numbers, right? I can make a dot at every single point on this number line for a value that is less than 17. So, in order to graph inequalities, we start by finding the number that is in the problem. So let's start by finding that number 17. So at the 17, I'm going to make a circle. So you should be making a circle. Now, I have to decide, is the sign that they're telling us to use less than or less than or equal to? The word problem is less than. So that means that we're going to leave that dot as an open dot. If the word problem said less than or equal to, we would be making a closed dot. We would be including that value of 17. But for now, we're using the open dot at number 17. And now we want to represent all numbers less than 17. Well, all numbers less than 17 will be moving left on the number line. So I just represent my graph by making a straight shaded line to the left of 17. And that shows me that Henry could be thinking of any number less than 17, but not including 17. So if I wanted to just sketch this on my own, I would make my number line. I would plot the point 17. I'm going to make an open circle at 17, and then I'm going to shade it to the left. And that shows me that Henry's thinking of some number that's less than, but not including 17. So now let's look at example 1, and you can just watch this as we read it together. An inequality uses greater than, less than, greater than or equal to, less than or equal to, or not equal to compare two expressions. Graph all solutions of x is greater than 5. So step 1 says to graph x is greater than 5. Draw an open circle at 5 on the number line. So let's start by making a number line in your notebook, and let's make an open circle at 5. Now we know that this is going to be an open circle because we have just x is greater than 5. It's not including 5. But let's look at step 2. It says find some solutions and plot them on a number line. So if x is greater than 5, we could plot 6, we could plot 7, we could plot 8, we could plot 1,000, all numbers greater than 5. Could I plot 5? Would I want to make a colored in circle at 5? No, I wouldn't, because x has to be greater than 5. So now step 3 says that I would start at the open circle and shade the solutions that I found. So that means I'd be shading in all numbers on the number line to the right of 5, because 5, it has to be greater than 5. Okay, next let's look at this try it question. It says there are no menu items on the children's menu at the Flamingo restaurant that cost more than $8.50. what are all the possible costs of the items on the children's menu? Okay, so there are no menu items that cost more than $8.50. So that means that it's all of the menu items, I'm going to call it X, will be less than or equal to $8.50 or 8.5. So let's start by making a number line in your notebook. And we're going to start by plotting a point at 8.5. So let's start by plotting an open point. Now we have to think, can X be 8.5? Let's think about what this inequality says. X is less than or equal to 8.5. So yes, I'm going to color in that 8.5 because X can be 8.5. X can be any number that's at 8.5 or lower because there are no menu items on the children's menu that cost more than $8.50. But they can cost $8.50. They can cost $6. They can cost $5. They can cost $4. So we would shade all numbers to the left, which is less than 8.5. So that's how we would graph that. And notice how we're shading in that point at the 8.5 because now our inequality has that or equals to line. So sometimes people remember the or, that we have to shade in on the or equals to line because we have extra ink down here when we make the equals sign. So you have to use extra ink to make your dot. That's one strategy that I know people sometimes think. So that might help you to remember to shade in also. For the last two questions, I want us to look at 6 and 7. It says in 6 and 7, write the inequality that each graph represents. So for 6, I have to figure out Z is either going to be greater than, less than, greater than or equal to, less than or equal to, what number? So it's easier to start by looking at the number line for 6 and figure out, well, at what number is there a circle plotted? So I see a circle, a point plotted at point 14. So that tells me I'm going to be having Z some sign 14. Okay, so let's see, is it shaded on all numbers less than 14 or shaded blue for all numbers greater than 14? So Z is shaded for all numbers less than 14. And now we have to decide, is the 14 colored in? Will it be less than or equal to, or is it open, so it's just less than? It's open, so it's just less than. And last one for number 7. Let's see, we have D. We're going to have some inequality symbol, and then we're going to have a number. So I think it's easiest to figure out what number the point's going to be at, what number we'll have to write for our inequality. So what number is the first point at? The first point is at 18. So we're going to have D some sign 18. So let's figure out, is the number line shaded for all numbers to the left of 18, less than, or all numbers greater than? D is going to be greater than 18 because 19's shaded in, 20, 21, 22. Those are all numbers greater than D. Well, let's see, is 18 also going to be included? Can D be 18? Yes, it can because it's shaded in. So then we're going to have the greater than or equal to sign.